We'll go straight into examples. Sketch the following functions. Indicating all the intercepts and turning points. Yeah. A f of x is equal to f of x is equal to 2x power 3 minus x squared plus 2x plus 1. So this is a polynomial function. So we put a minus here. Okay. So I want to sketch this function. So whenever you're taught to sketch a function, the first thing that you do, you look for, since you are taught to indicate all the intercepts and turning points, you look for the intercepts first. So let's start with the y-intercept, the easiest. Where there is x, you put 0, you get 1. And so we have 0, 1. Then you go to f and equate it to 0 so that we obtain the x-intercept. So we have 2x3 minus x squared minus 2x plus 1 is equal to 0. When x is equal to 1, we're now looking for the zeros, the same way we used to solve polynomials. So we'll have 2 minus 1 minus 2 plus 1, which is 0. So you can use synthetic to reduce this function. Using 1, we have 2, negative 1, negative 2, positive 1. Then we drop the 2, multiply, we get 2, add, get 1, multiply, we get 1, add, we get negative 1, multiply, we get negative 1, add, we get 0. So we're saying f of x is the same as x minus 1, this one here, and then 2x squared plus x minus 1 is equal to 0. This means that if you look at this function here, we're able to factorize it. The product is negative 2, and the sum is 1. So we'll have x minus 1, and then 2x squared plus 2x minus x minus 1 is 0. So get x is 1, or 2x, x plus 1, negative 1, x plus 1 is 0, so that x is negative 1, or x is positive half. So this means that we're almost able to sketch this function. We have the intercept for x, we have the intercept for y. If it was just a normal polynomial like we used to do before calculus, would have found, we would have sketched it already. So now we need to look for the intercepts. We need to look for the turning points using calculus. So you differentiate f for you to find the x coordinates of the turning points. The derivative of f is going to be 6x squared using power rule here minus 2x minus 2. And then equate this derivative to 0. We divide throughout by 2, divide by 2, we get 3x squared minus x minus 1 is equal to 0. So we can use the formula here. This is going to be 1 plus or minus the root of 1 plus 12 over 6. So we get 1 plus or minus root 13 over 6. So we can sketch. The only critical part in our case here is that it's going to be hard. We're supposed to substitute these numbers here in the original f, 1 plus root 13 over 6. This to the power 3.
So
Hello.
how did you come up with the 2 down there? I'm a bit lost.
Which 2? This one here.
Yes,
I said
yes, the recent one.
since 2 is common, we can divide throughout by 2. Because there's 2 in 6,
right.
there's 2 in 2, there's 2 in negative 2.
All right.
So we're supposed to substitute this in the original function for us to get the corresponding value of x. But unfortunately, this can take us so much time. So this means that we'll just do an estimation for this case. So we have the intercept -1, half, and +1. And the y-intercept was the first thing to get. Where is it? 0,1 here. And then we have 1 minus root 13. What number is smaller than 1? And then we also have 1 plus root 13. That number is 2 point something. Okay. Oh, it's 1 point something. Was root 3, let's see. In fact, even less than 1. 1 plus root 13 over 6. Okay, so this means that this guy is going to be turning somewhere here and then come down to cross at half, turn somewhere here, and then go up. So we couldn't just find these, which we are going to be found by substituting these values of x in the original function.
So, sir, there's no any other alternative on how to go about this question.
What do you mean by
Now, sir, in terms of the one which have got a cube root, a cube root.
how do you ask the question proper? What do you mean by any other way?
So,
Hello.
So, so you are saying whenever we're given such questions, if you want to solve them using calculus, I'm a little bit behind on the which step is this? Not behind, but I don't know if what I'm thinking is correct because I did not get you clear. First, after you find the y coordinate, the y intercept, then again you find the x intercept using whatever method you can use. Let's say, for instance, this one we've used the synthetic division. Then after that, you find the derivative of the original function. Then from there, you find the x coordinates. Now, are those x coordinates the coordinates of the turning point?
Yes.
Then then now you find the y.
Exactly.
Okay, so
That is if we had normal functions.
Sir.
Hello?
Yes, sir. My question, my question is similar to what he has asked. I just want to be clarified on this point where you are finding the y-intercept. So after you doing the synthetic division for the cube of 2x cubed, this function, you found the x you found was it equals to 1, and then for the y, did you replace the x in the function to find the y, or because I haven't seen how you got the y and how the graph has come about?
Another question?
Question
Hello?
for the question I haven't really understood. It's not really a question, but I just haven't understood.
Okay.
Sir, can you just please go to the whole question?
All right. Another concern? I want to attend to everyone at the same time.
Yes, I just want you to go through the question again.
Sir,
Hello.
And then when substituting, you're substituting the number less than that number there, the 1 plus 13 over 6. Are you are you substituting the number less or more? That's what is there on the graph.
Maybe next weekend. All right. So you have brought forward all the concerns. All the concerns brought forward. I've attended. Hello. So I'm trying to find a nice question that is going to help me explain. Let me just get from where I get questions from. It's not coming.
Now, sir, sir, the question on the previous screen. Here we actually found the turning point. But how did you find the y-intercept? Why you say that here it's turning on this side?
So B f of x is equal to x to the power 3 plus 3x squared plus 3x plus 1. I said the first thing to do is to find the y-intercept. So in the function where there's x, you take 0, we're going to get 1. So we are saying the y-intercept is 0, 1. Second, we find the x-intercept by equating f to 0. So what is f of x is equal to 0? This is going to be x3 plus 3x squared plus 3x plus 1 is equal to 0. This is a polynomial, so you look for a factor. So let's try x is equal to -1. We have -1 to the power 3 plus 3 -1 squared plus 3 -1 plus 1 is equal to, let's see if it satisfies the equation. So we'll get -1 plus 3 minus 3 plus 1, which is indeed equal to 0. What does it mean? It means that we can now use synthetic division with -1 as our factor, and then 1, 3, 3, 1. Then 1 down. -1 times 1, -1.
So that's -3. 1 is -3.
We are getting the coefficients of the original polynomial. They are positive, is it? So here we'll get 2 and then multiply again. We'll get 1, multiply, we'll get 0. Then f of x, since already equated to 0, we are saying x plus 1 now, y plus 1, because this is negative here. When the factor is negative, we use plus, multiplied by x squared plus 2x plus 1 is equal to 0. So x is equal to -1. We factorize here, we'll get x squared plus x plus x plus 1 is 0.
Isn't it supposed to be -3?
Where?
There on the synthetic division, isn't it supposed to be -1, 3, then -3, then 1?
So you correct the coefficients of the original polynomial, not when you substitute a number. Okay, so we have x plus 1 plus 1, x plus 1, so that we get x plus 1, x plus 1 is equal to 0. So here we only have x is equal to -1 again. So the only turning point that the only intercept for x that we have is x is equal to -1. Okay. Then from there, we now look for the turning points. The turning points, you differentiate the function. What is f prime of x? It is 3x squared plus 6x plus 3, and then equate it to 0. We divide throughout by 3, divide by 3, we're going to get x squared plus 2x plus 1 is equal to 0. This is what we just factorized here. So it's going to give us x is equal to -1. Then you get this -1, take it in the original function for you to find its corresponding its corresponding y coordinate to form the full point. So we're going to have f of -1. Hello?
Sir, just there before I'm lost, where are you getting x equal to -1? After differentiating that, yes, sir, we followed there. But where the -1 is coming from?
So this is what we have here.
Okay. Thank you.
All right. So you take this -1 in the original function, we are going to get 0. So that -1, 0 is our turning point. So how do I get the turning point? I differentiate the function. So for x, the values of x I get, you take in the original function for you to obtain the turning point.
Sir. Sir.
So,
Sorry to disturb the time your explanation. To use completing the square, like when we're doing polynomials. So as we have learned about the application of derivative by using you differentiate the function and then you find the turning point. Can that be applicable even if when we use it maybe in the exam or something?
Sammy, I have a question.
Before another one, you're asking that if this question was to be on completing the square, and you use the derivative to find the turning point.
No, I'm not saying on completing the square. Yes, like they tell you to graph this function, and then they even tell you you're supposed to show the turning point.
Yes.
Like I remember when we were taught by Mr. Our lecturer said we're supposed to only use just completing the square, but of the knowledge that we have gained in derivatives, where you can use you can differentiate the function and then you find the turning point. Can that be okay if I use that when I'm answering such questions?
Polynomial questions, you don't complete the square. Polynomial questions, okay, you differentiate. Quadratics, if you are told to complete a square, you complete the square.
Okay.
If you are not told, you can differentiate.
Okay.
Yes.
Sir.
Yes.
Sir, I was asking, so we only have one x-intercept?
Yes.
Why?
That's the one we found. After I factorized the function, it was giving us the same value. So we only have one.
Okay, so what if in the case of we have different values of x?
This case first. This case is not yet done.
All right, thank you.
So we sketch it.
Sir, I'm so confused that side. Like when you are using the derivative there, and where we have this equation, like is this just the same thing, or maybe you were trying to find the turning point, or you were just showing us the other
this is the turning
way
point.
of finding?
This is the turning point.
The one that the one that we have used synthetic
this is
equation.
the x. This is the x-intercept.
Now why is it giving us the same value? Like -1 here, -1 there.
That's how they made it.
No, don't worry. We're going to say a lot of things in this one. We don't have to question everything. So we're getting -1. Okay. Now, what happens before -1? This number I've gotten here. Remember, we're saying the turning point is -1, 0. Okay. We want to see if it is maximum or minimum. So what do I do to check if this turning point I found is maximum or minimum? I go back to my derivative and differentiate it again. So we're going to have f prime prime, meaning we differentiate the derivative that we have. We differentiate it again. So 2 by 3 will get 6x plus 6. In this derivative, we bring -1. So when you bring -1 in this derivative, we are getting -6 plus 6, which is equal to 0. So unfortunately, the second derivative cannot help us to know whether this is a maximum or minimum turning point. So what other methods then do we employ? You say, okay, since the second derivative can't help me, I'm going to use the normal way of graphing polynomials. What we are doing, you would get a number after and a number before. So since we have -1, and when it is 0, we already know that for 0, we are getting, a +1. That's why we have 0,1 here. So it means that numbers above -1, the numbers bigger than -1, we're getting positive. So let's check for before -1. Let's pick -2. We have f of -2. This is going to be -8. I'm substituting in the original function. So we get -8 plus 12 minus 6 plus 1. What do we get? That is -14 plus 13, which gives us -1. Okay, so this means that our graph is going to be down here on this side because you're getting -1, a negative number. So then you come back and sketch this function. So it's going to be a function of this form. Very, very nice behavior. So this is a function. That's how it's going to look like.
So why did we use the negative?
We just
How
wanted
many
to
marks service one?
We're just surrounding -1. We checked on its right and on its left. How many marks? It was an exam question. There were no marks put here.
Sir,
Hello.
you can just repeat on the part where you're like the part for the derivative when you find the derivative.
Okay. Any other question?
Yeah, let's just do another example.
Okay, thank you. So this second comment is very, very nice. So I'm going to explain how the derivatives are
This
happening.
graph is just like
Sir, I have a concern. Sir,
What's the concern?
yes, when we substitute when we second we substitute when we second derive the first derivative, this
Yes.
simplified one, and then we substitute in negative one to find if it is negative or minimal. It is
Get
working.
zero.
This simplified one.
No. You get 0. It will be 2x plus 2.
Oh, 2x plus 2.
Exactly.
Oh, all right.
Sir.
Yes.
Okay, before you even shift to the other question. So the negative, this turning point that we found, -1, 0, is it the one that is here to the left? Is it where the graph is passing there?
This one here. Yes.
Okay. What about where this the positive one? How is it?
That's the intercept. That's the y-intercept.
Or the y-intercept?
Exactly.
Or we found it after we had put 0 in the one or the
Yes,
x?
it was our first thing to do.
Okay. Okay. But what about this negative that you found down here, sir? Sorry to, this negative down here.
We're testing the sign of the function for numbers less than -1. So the
So
sign
you're
was
supposed to do
negative.
that before.
Yes.
Okay.
If you don't have any
Let me do another
information
example,
on
sir.
how the graph is going to come.
Okay.
Okay, so since we are using Zoom, let's log out and quickly come back because we're not waiting long. We'll start immediately. One person joins. We can start.